Good morning. We're going to start the second half of Unit 5. Unit 5 transitions. It's similar to exponential functions, but we're transitioning to the perspective of geometric sequences.
So our EQ statement for this one is, what is a geometric sequence and how do we use the explicit and recursive formulas to find the nth term or the next term in a sequence? So we need to know some vocabulary words. So geometric sequence is a series of numbers that has a common ratio, r, between each of the two consecutive terms.
Now the nice part is we in Unit 2 did arithmetic sequences and series, so therefore this should be a nice easy transition because now instead of adding or subtracting, we're multiplying or dividing each time.
So then we need to recall the explicit formula, which states is used to find the nth in any term of a geometric sequence. So t to the nth sub n is the last term in the sequence, t to the first is the first term, times a common ratio by tn over tn minus 1, and then we have n equals number of terms.
So your formula is t sub n equals t sub 1 times r to the n minus 1 power. So make sure you make note that this is an exponent, not being r times n minus 1.
And then the wonderful recursive formula used to find the next term of a geometric sequence using the previous term. So our first term is t sub 1 equals the number that we start with, and t sub n equals r times the tn minus 1. So the common ratio times the previous term.
And so I will tell you, we're not going to assess on the recursive formula, but it is useful. It's actually probably easier than the explicit formula itself. So let's get started with writing the explicit formula. So first we're going to write, make sure you make notes somewhere that you have your explicit formula of t sub n equal to t sub 1 times r to the n minus 1 power somewhere so that way you don't have to keep scrolling through your notes. And we've got the sequence 250, 100, 40, 16. And we need to find the common ratio. We know that it's getting smaller, so that's like we're dividing, but really that means we're going to multiply by a fraction because we want to have our ratios to be all multiplying. That means we need to take term 2, which is 100, divided by 250, which is really like 10 over 25. They're both divisible by 5, so we get 2/5. So 2/5 is our ratio. You could actually just stick it into a calculator as well if you would like. So then we need to find the next term in the sequence, which means I'm going to take 16 times 2/5. 16 times 2 is 32 over 5, which you could also change that to 6 and 2/5 if you would like, or 6.4. T sub n as t sub n, because otherwise we won't be able to find any term. We need to have term 1, which is 250, and then r, which we established is 2/5, and that'll be to the n minus 1 power. Moving on to the next example. We need to also be able to identify if it is or is not geometric. So we look here. To get from 2 to 4, in order to be geometric, we have to multiply by something, so this would be times 2. Well, I see that 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So yes, this is geometric. And then if it is, we need to identify the common ratio, which we did. So r is 2. And then find the next 3 terms. So that means we need to take 32 times 2, which is 64. Take 64 times 2, which is 128. And then take 128 times 2, which is 256. So this is really a 3-part problem. The next one, to get from 2 to 4, we multiply by 2, but 4 times 2 is not 6. So this, we can stop there and say not geometric. The next piece is if I give you the explicit formula, which in this case is t sub n equal to 4 times 2 to the n power, we're going to list the first 4 terms. That simply means that if we're finding term 1, we're going to put in 1 for n. So 4 times 2 to the first. 2 to the first is 2 times 4 is 8. We know that r is 2, so we technically could go from there, but I'm going to show you how you can, if you didn't see that. 4 times 2 to the second. 2 to the second is 4 times 4 is 16. You should be able to see that we're doubling. This would be 32. This would be 64.
Make sure you're putting down your work so that we can help you if you make mistakes and finding what mistakes and where they are to help you understand it.
Right, because as some of you noticed when you did standard check 1 dealing with growth and decay multipliers, some of you got a wrong answer, and there were a couple of you I could not help with figuring out what you did wrong because you showed no work. Now we have the geometric sequence. We need to write the explicit formula and then use it to find the 10th term. So I see, first I need to find r. That is going to be 12 divided by 3, so r is 4. We know term 1 is 3. So that means that my explicit formula will be term n equals term 1, which is 3, times r, which is 4, to the n minus 1 power. And I like it if you put the r in parentheses. It'll make your life easier with keeping track of things because it'll show some consistency. Then we want to find the 10th term, so t sub 10. So that means we're going to take 3 times 4 to the 10 minus 1 power. So 10 minus 1 is 9. So we have 3 times 4 to the 9th power. I have a couple of you that keep wanting to take 3 times 4 is 12 and take 12 to the 9th power. First of all, that is a huge number. And second of all, that's not how you do. You have to take 4 to the 9th first. Put it in the calculator. 3 times 4 to the 9th, exactly as you see it written. And what do you get?
262,144.
262,144.
And then you would multiply that by 3, and you would get 786432.
So, as you can see, these are geometric sequences. As we know from exponentials, they jump up pretty quickly, so you should expect to get either really big or really small numbers, depending on whether the sequence is increasing or decreasing. The last part is using the recursive formula to find the first 4 terms. I gave you the first one. Term 1 is 18. And it says I'm going to take the previous term, term n minus 1, so in our case is 18, times negative 2. So this would be negative 36. Then I recycle that and take negative 36 times negative 2 to get positive 72. Then I recycle that number again and you take 72 times negative 2 to get negative 144. You will get some terms or some sequences that terms do what I call oscillating, where it goes back and forth between positive and negative all the way through. What I need you to do now is try some of these U-try problems. The first one, determine if the sequence is geometric, and if so, identify the common ratio. Then the second one, I give you the geometric sequence. I want you to find the explicit formula, and then find the 30th term. And then the final one, here is the recursive formula with term 1 equal to 6 and term sub n equal to 3 times the previous term. Find the first 4 terms of the sequence, and then find the 5th. So basically find the first 5 terms. Make sure you write your summary, and as always, bring your questions with you to class.